Welcome to our deep dive into the life of Ernest Rutherford. This guy's story is wild. He was making groundbreaking discoveries his whole career, even after winning a Nobel Prize. Just imagine. Imagine a life where you're constantly pushing the boundaries of what we know about the universe. That was Rutherford. And today we'll use excerpts from a biography to explore how he went from a kid in New Zealand to the father of nuclear physics.
It's remarkable, isn't it? His work was so fundamental to our understanding of atoms,
Yeah.
radiation, everything in between, really.
I know. We're talking about someone who coined terms like alpha ray and beta ray, terms we still use every day. That's the kind of lasting impact Rutherford had. And get this. He initially thought there might be something called nuclear electrons inside the atom.
Science is all about constantly revising our understanding. Even brilliant minds like Rutherford had to adapt as new evidence emerged. It's that very process that led him to some of his biggest discoveries.
Okay, let's rewind to the beginning. Rutherford was born in New Zealand, the fourth of 12 children.
12 children, that's a full house. You have to wonder if all that sibling interaction influenced his collaborative approach to science later on.
He always had a curious mind, excelled in school, and even turned down a government job to finish his education. That's dedication. His pursuit of knowledge led him to Cambridge University, one of the most prestigious institutions in the world, even though he didn't have a Cambridge degree himself.
He was one of the first aliens allowed to research there. It's a testament to his talent and drive that he was able to break into that world. At Cambridge, he worked with J.J. Thomson,
Yeah.
Who discovered the electron. Imagine the energy in that lab, with these brilliant minds working at the forefront of scientific discovery.
It must have been incredible. And speaking of pushing boundaries, Rutherford wasn't just focused on the theoretical. He even developed a new radio wave receiver and set a distance record for detecting them.
Of course, Marconi ended up beating his record. But it shows how Rutherford was always drawn to the cutting edge of technology. He wanted to see what was possible.
But his real passion was radioactivity. It was at McGill University in Canada where he really dove deep into this new field. Along with Frederick Soddy, they identified a new element called thoron, which we now know is radon. This was groundbreaking.
The discovery of any new element is always exciting. But it's worth pausing to appreciate the dedication and meticulous work it takes to isolate and identify these substances. And it didn't stop there. Think about how we understand radioactive decay today. It's all thanks to the concept of half-life that Rutherford and Soddy defined through their meticulous experiments.
It really revolutionized our understanding of how atoms change over time, and they didn't stop at just defining the process. They even theorized that radioactivity could be the energy source for the sun. It's amazing how their work linked the microworld of atoms to the vastness of the cosmos.
They were challenging the prevailing view that atoms were indestructible. Rutherford and Soddy's work showed that atoms could actually break down, disintegrate, and even transform into other elements.
It's a total paradigm shift, and all this groundbreaking work culminated in Rutherford receiving the Nobel Prize in 1908 for his investigations into the disintegration of elements and radioactive substances.
It's fascinating that he actually received the Nobel Prize in chemistry, not physics. Back then, the lines between those fields weren't as clearly defined as they are today.
Right. It speaks to how interconnected these different scientific disciplines really are. But even with a Nobel Prize under his belt, Rutherford wasn't done. He was about to make an even bigger splash in the world of physics. And it all started with a piece of gold foil.
That's right, the famous gold foil experiment. But let's not forget it was actually led by Hans Geiger and Ernest Marsden. Under Rutherford's direction, it was truly a team effort, and often the principal investigator gets all the attention.
So what were they trying to figure out with this experiment? Were they aiming to prove the plum pudding model of the atom? I think it would be helpful to refresh our listeners' memory on what that model even looked like.
Absolutely. Imagine a plum pudding, where the pudding represents a diffuse positive charge, and the plums scattered throughout are the negatively charged electrons. That was the dominant idea about the atom structure at the time. Rutherford and his team thought, okay, if this model is accurate, then alpha particles, which are basically helium atoms without their electrons, fired at a thin sheet of gold, could mostly pass straight through, with maybe some minor deflections.
But that's not what happened at all. The results were shocking.
Some of those alpha particles bounced back at incredibly sharp angles. It was like firing a cannonball at tissue paper and having it come back and hit you. Rutherford himself was completely taken aback by this.
What a mind-blowing discovery. How could they explain these results? It clearly challenged the plum pudding model.
It forced Rutherford to rethink the atom's structure entirely. He proposed that the atom must have a tiny, dense, and positively charged core at its center, what we now call the nucleus. This is where most of the atom's mass is concentrated, and it's what caused those alpha particles to bounce back in such a dramatic way.
So the gold foil experiment basically revealed the existence of the atomic nucleus. That's monumental. It completely changed our understanding of matter. It laid the foundation for all future models of the atom, didn't it?
It absolutely did. And Rutherford, always pushing forward, continued to refine his nuclear model of the atom. This led him to collaborate with Niels Bohr to develop what we now call the Bohr-Rutherford model, combining Rutherford's insights about the nucleus with Bohr's work on quantum mechanics.
This model explained how electrons orbit the nucleus at specific energy levels, right? But all this was happening right before World War I broke out. Did the war interrupt Rutherford's research?
You might be surprised to hear that it didn't. Rutherford was a patriotic guy, and he contributed to the war effort by researching piezoelectricity.
Piezoelectricity, that's the ability of certain materials to generate an electric charge when they're squeezed or pressed, right?
Exactly. Remember those gas lighters that make a clicking sound when you press them? That's piezoelectricity in action. Rutherford's research in this area actually laid the groundwork for early sonar technology, which was critical for detecting submarines during the war.
So the periodic table is based on atomic number, which is directly related to the number of protons in an atom. Okay, that makes sense. But how did this lead Rutherford to actually discover the proton?
He had been theorizing about a positively charged particle within the atom, something he initially called a positive electron. Of course, the electron was already known to be the negatively charged particle. So the idea of a positive electron was a bit confusing at the time. But through a series of experiments, Rutherford bombarded nitrogen gas with alpha particles and observed particles being emitted that behaved just like hydrogen nuclei.
So he realized that these hydrogen nuclei were actually coming from inside the nitrogen atoms.
Exactly. He had essentially knocked protons out of the nitrogen nuclei, confirming his earlier theory and officially naming this positively charged particle the proton.
It's amazing how he was able to probe the very heart of the atom and isolate these fundamental building blocks.
It's a true testament to his experimental genius, an unwavering determination to understand the nature of matter. But even with the discovery of the proton, there was still something missing, a piece of the nuclear puzzle that remained elusive.
I'm guessing you're talking about the neutron.
You got it. But that, my friend, is a story for part 2 of our deep dive. Stay tuned.
Welcome back to our deep dive into the life and work of Ernest Rutherford. Last time, we left off with the discovery of the proton. But as groundbreaking as that was, there was still a crucial piece missing from the picture, wasn't there?
There was indeed. We were left with a puzzle. The protons and the nucleus. They should repel each other. So how does the nucleus stay together? The answer lay in the discovery of a new particle, one that proved even more elusive than the proton.
You're talking about the neutron, right? But why was it so difficult to find?
The neutron, unlike the proton or electron, has no electric charge, so it wouldn't interact with electric or magnetic fields. In the same way, making it much harder to detect. Imagine trying to grab a shadow. That's how tricky it was to pinpoint the neutron.
It sounds incredibly challenging, but even without being able to directly observe it, Rutherford still suspected its existence, right?
He did. He was convinced there had to be something else in the nucleus, besides just protons. Something to explain both the atom's mass and its stability. He even gave this hypothetical particle a name, the neutron.
So he not only predicted the existence of the neutron, but also gave it its name. Pretty impressive. But what led him to believe in this mysterious particle so strongly?
Well, there were a couple of key reasons. Firstly, the measured mass of atoms just didn't add up if you only considered the protons. There had to be some other neutral particle contributing to the atom's overall weight. Secondly, think about the nature of electric charge. Like, charges repel each other, right? So how could the nucleus hold together if it was just a bunch of positively charged protons all crammed together? They'd push each other apart.
That's a great point. It would be like trying to force the same poles of two magnets together. They just want to spring apart.
Exactly. So Rutherford theorized that these neutrons must be present in the nucleus to act as a kind of nuclear glue. They would provide a force to counteract the repulsion between the protons and keep the nucleus stable.
It's such an elegant solution. So how did they finally track down this elusive neutron?
Rutherford initially thought there might be what he called nuclear electrons inside the nucleus, somehow canceling out some of the positive charges from the protons.
Nuclear electrons. But didn't we already establish that electrons orbit the nucleus? How could they be inside it?
You're right, it seems counterintuitive now. But remember, this was a time of tremendous change and upheaval. In our understanding of the atom, scientists were constantly revising their models and trying to reconcile new experimental findings with existing theories.
So, was Rutherford's idea of nuclear electrons correct? Did that turn out to be the missing piece of the puzzle?
It was a step in the right direction, but it wasn't the complete picture. He was close, but he was missing one critical insight, and it was his associate, James Chadwick, who ultimately made the breakthrough discovery.
Ah, so this is where Chadwick enters the story. He's the one who's credited with the discovery of the neutron, right?
Yes. He was working in Rutherford's lab at Cambridge when he noticed something peculiar in his experiments. He was bombarding beryllium with alpha particles, and he observed a new type of radiation being emitted that didn't behave like anything they'd seen before.
What was so strange about this new type of radiation? What made it stand out?
For starters, it wasn't affected by electric or magnetic fields at all, which told them right away that it had to be neutral, no electric charge. But the real clincher was that it had roughly the same mass as a proton.
So this was it. They'd finally found the neutron. It had the right properties to fit Rutherford's predictions.
Exactly. Chadwick had uncovered the missing piece of the puzzle. His discovery provided concrete proof of the neutron's existence and validated Rutherford's earlier ideas about what held the nucleus together.
This was a huge moment for nuclear physics. It finally explained how the nucleus could be stable, despite the repulsion between all those protons.
Absolutely. And it's important to remember the historical context here. This was the early 1930s, a time when the world was on the verge of major scientific and technological advancements. The discovery of the neutron opened up entirely new avenues of research and paved the way for the development of nuclear energy.
Speaking of new avenues, Rutherford wasn't just the theoretical mastermind, right? He was also known for his love of hands-on experimentation.
Absolutely. He wasn't content to just sit back and theorize. He loved to tinker, to build things, to test his ideas in the lab. And under his leadership, the Cavendish Laboratory at Cambridge became a hotbed for innovation and discovery.
It was practically a Nobel Prize factory. So many groundbreaking discoveries came out of that lab during Rutherford's time.
It really was an incredible time for science. And in addition to Chadwick's discovery of the neutron, two of Rutherford's other students, John Cockcroft and Ernest Walton, accomplished something truly remarkable. They split the atom.
Split the atom? That sounds dramatic. How did they manage to do that?
They used a particle accelerator, a device that uses electric fields to speed up charged particles to incredibly high speeds.
I'm assuming this wasn't some simple tabletop experiment. They must have needed some serious equipment.
You're absolutely right. They used a cutting-edge piece of technology for the time. Their accelerator allowed them to slam protons into lithium atoms with enough energy to actually break the lithium atoms apart.
And what happened when they split the atom? Was there some kind of massive explosion?
Not quite a Hollywood-style explosion, but they did observe the release of a significant amount of energy during the process. And this confirmed Einstein's famous equation, E=mc², showing that mass could indeed be converted into energy.
So they experimentally verified one of the most profound concepts in physics.
They did. And this discovery would have far-reaching consequences. Particularly for the future of nuclear energy, it was a pivotal moment in our scientific understanding.
It's incredible to think that all of this was happening under Rutherford's watch at the Cavendish Laboratory. He really cultivated an environment where scientific breakthroughs could flourish.
He was more than just a brilliant scientist. He was an exceptional mentor and leader. He inspired generations of physicists to push the boundaries of human knowledge.
And his influence went far beyond the lab. He was recognized worldwide for his achievements, wasn't he?
He certainly was. He received countless awards and honors, including a knighthood, and even a peerage, becoming Baron Rutherford of Nelson. He also used his platform to advocate for the importance of science and education in society.
He understood that scientific progress wasn't just about discoveries in the lab. It was about sharing that knowledge and inspiring others to follow in his footsteps.
He was a true believer in the power of science to improve the world. But sadly, even geniuses aren't invincible.
What do you mean? Did something happen to Rutherford?
Unfortunately, yes. He passed away in 1937 at the age of 66, due to complications from an untreated hernia.
That's so sad to hear. It sounds like he was still in his prime, with so much more to offer the world.
It was a significant loss for the scientific community. However, even though his life was cut short, His legacy continues to inspire and impact us today.
I can only imagine how different the world might be if he'd had more time to continue his work. But what about his legacy outside the world of science? I know he's quite a national hero in his native New Zealand, right?
Absolutely. He's featured on the New Zealand $100 bill, and there are numerous memorials and institutions dedicated to him throughout the country.
That's fitting, considering how much he achieved in his lifetime. But his impact extends far beyond New Zealand, doesn't it?
Of course, he's considered one of the most important figures in the history of science, period. His discoveries revolutionized our understanding of the atom and laid the foundation for countless technological advancements that we rely on today.
So what can we, the non-scientists, learn from Ernest Rutherford's extraordinary life? What lessons can we take away from his story?
I think there are several key takeaways that are applicable to everyone, regardless of their field. Firstly, never stop questioning. Rutherford's relentless curiosity fueled his groundbreaking discoveries. He never lost his childlike wonder about the world and was always asking why.
That's such an important reminder for all of us. Sometimes we get so caught up in our routines that we forget to question, to explore, to be curious.
Exactly. And Rutherford wasn't afraid to challenge conventional wisdom, even when it meant questioning his own assumptions. He was always open to new ideas and perspectives.
And that open-mindedness is crucial for growth, both personally and professionally.
Absolutely. Secondly, we can all learn from Rutherford's emphasis on collaboration. His greatest achievements were the result of working with others, sharing ideas, and building upon each other's strengths. He cultivated a truly collaborative environment at the Cavendish Laboratory, and that's something we can all try to emulate in our own lives.
It's a reminder that we can achieve so much more when we work together towards a common goal.
Exactly. And finally, it's crucial to remember that scientific progress isn't always a straightforward, positive thing. It's a double-edged sword, capable of both improving and endangering our world.
That's a sobering thought. It's easy to get caught up in the excitement of new discoveries, but we have to be mindful of the potential consequences as well.
Rutherford himself understood this. He lived through World War I and witnessed firsthand the devastating applications of new technologies. It made him acutely aware of the responsibility that comes with scientific progress.
It makes you wonder how he would view the world today, doesn't it? With all the advancements in nuclear technology, both for energy and for weaponry.
It's a fascinating question to ponder, knowing what we know now about the potential benefits and risks of nuclear power. How would Rutherford view this technology in the 21st century? Would he be excited by the progress we've made in harnessing the power of the atom? Or would he be horrified by the destructive potential we've unleashed?
It's hard to say for sure, but it's definitely something to think about. But we'll delve into those questions and more after a quick break. Welcome back to our deep dive into the world of Ernest Rutherford. Before the break, we were discussing how his groundbreaking work in nuclear physics led to some pretty profound questions about the future of nuclear technology.
Yeah, it's fascinating how someone who's considered the father of nuclear physics could be so skeptical about the practicality of nuclear energy, isn't it? He even famously dismissed the idea of harnessing power from atom transformation as moonshine.
Right. It really highlights the unpredictable nature of scientific progress. Even a visionary like Rutherford, who fundamentally reshaped our understanding of the atom, couldn't have foreseen the ways in which his work would be applied in the future.
Absolutely. It makes you wonder what he would think if he could see our world today. Nuclear power plants are generating electricity all over the globe, but we're also living under the constant shadow of nuclear weapons.
I imagine it would be a mix of awe and apprehension. He'd probably be amazed by the technological advancements we've made, but also deeply concerned by the potential for destruction.
It's a delicate balance, isn't it?
Yeah.
The power of the atom can be used for both good and bad. It's a powerful reminder that scientific progress comes with the responsibility to use that knowledge wisely.
Rutherford himself seemed to understand this. He lived through the horrors of World War I, which saw the devastating use of new technologies, like chemical weapons. That experience must have had a profound impact on his view of the potential consequences of scientific discovery.
You can see that awareness in his skepticism about nuclear energy. Even though he dedicated his life to unlocking the secrets of the atom, he was also acutely aware of the potential for those secrets to be misused.
It makes you wonder if he would have become more optimistic about nuclear energy if he had lived to see its peaceful applications, or if the threat of nuclear weapons would have only deepened his concerns.
It's a question we can only speculate on. But what's clear is that Rutherford's legacy is far more complex than just being the father of nuclear physics. He was a brilliant scientist, a gifted mentor, and a complex figure who grappled with the profound ethical implications of his own discoveries.
His story is a reminder that scientific progress is rarely a simple, straightforward path. It's full of unexpected twists and turns, unforeseen consequences, and constant reassessment of our understanding.
And that journey of discovery isn't just limited to scientists. It's something we can all embrace in our own lives.
I love that. So as we wrap up our deep dive into the world of Ernest Rutherford, what are some key takeaways our listeners can carry with them?
I think there are several valuable lessons we can all glean from Rutherford's life and work. First and foremost, never lose your curiosity. Embrace a childlike wonder about the world around you. Never stop asking questions and seeking out new knowledge.
That's so important. It's easy to get caught up in our routines and forget to cultivate that sense of wonder. But curiosity is what drives us to learn, grow, and make new discoveries.
Exactly. And don't be afraid to challenge the status quo, even your own assumptions. Be open to new ideas and perspectives, even if they conflict with your current understanding.
Rutherford was never afraid to question conventional wisdom, and that willingness to challenge existing ideas is what ultimately led him to his groundbreaking discoveries.
Another important lesson we can take from Rutherford is the power of collaboration. He fostered a culture of teamwork and shared knowledge at the Cavendish Laboratory, and that collaborative spirit was crucial to their success.
It's a reminder that we can achieve so much more when we work together, sharing our ideas and supporting each other.
And finally, as we continue to push the boundaries of scientific and technological advancement, it's important to remember that progress comes with responsibility.
It's crucial to think critically about the potential consequences of our actions, and to ensure that our advancements are used to benefit humanity, not to harm it.
So as you go about your day, we encourage you to carry these lessons with you. Keep asking questions, be open to new ideas, collaborate with others, and be mindful of the impact your actions have on the world around you.
That's a great way to sum things up. Thank you for joining us on this deep dive into the extraordinary life and work of Ernest Rutherford. We hope you learned something new, and maybe even feel inspired to explore the world with a renewed sense of curiosity and wonder.